It's Geometry Revisited, yeah? Chapter 2.
Oh,
You know how much
Huh? Yeah, but
you know for any module, you know for
but
any
this is stuff that we kind of mentioned before, but it's kind of stuff you know. So the power of a point
What is it? I asked once and then you were like, no,
with
that's not
respect to a circle. Yeah? Okay, so basically this is chapter 2.1, yeah? Okay, so you have a circle, and if you take two, yeah, and call this P, yeah? So the point that we're talking about is going to be P, yeah? Can you kind of see that? You know what the product of the, you know, the
intersecting chord.
yeah. So it's like let me label it like they label it.
It's just a similar triangles, right?
Yeah, so it's B prime here, A prime here. So that's A and that's B, right?
You lost.
Yeah, so PB times PB prime, right? Equals PA times PA prime, yeah? Yeah, and you can see like, you know, maybe this could do this.
And it holds when it goes outside.
Right? So there's similar triangles here, right?
Yeah.
Yeah, it holds and it goes outside the circle as well. So yeah, so I guess maybe you can convince yourself, or you already seen it, that so it holds if one of those things is a tangent, right? So if it holds, if it's like and then it's like a tangent here, right?
You know, on Sunday we had like, I had a choir. Like I mean, 3, 2. No, I don't. Just go.
Kind of like this.
Just making choir.
I guess this would be P, yeah? So it works if it's a tangent, yeah? Because that's just a special case where that moves out, yeah? And obviously this could also be another tangent, yeah? So that's not mentioned in the book, but
that'd be like square.
yeah, that'd be, so the tangent means just this squared equals that times that, right? If they're both tangent, it's just squared equals squared, but they're both positive, so they're just equal, yeah? Okay. So that's basically what the power of a point is, yeah?
Two tangents from two tangents.
Oh really? Is that what?
Yeah. So because because no matter where, so if you take the point, right, no matter where you take the products of the intercepts, right, it gives you the same number. So then it only depends on the point and the circle, right? It doesn't depend on the actual chord, right? So the power of the point is basically defined to be okay. So
the two tangents coming from a single point must be equal then.
yeah. So that's a special case of this as well, right?
Because like one, the similar triangle, so one is just the ratio of the other, and then so you multiply it by a ratio and then multiply it by a reciprocal.
Yeah. So you can take a point P, right? And you can take its distance D from the center of the circle, right? And then I guess you can take the radius.
Projected through a circle or something.
D squared minus R squared.
That doesn't count.
Yeah, so that's a tangent, yeah?
Yeah.
And this is the radius.
Wait, what was the thing?
So they define power of a point to be D squared minus R squared.
72.
Okay.
Oh.
But you know the point is it's meant to be equal to all these other things as well. Yeah, see, because you guys are retarded.
I can't tell something like that now.
Why something like funny?
Okay, so
That angle doesn't look like a right angle.
TC.
Yeah, I could have drawn it better. Should I draw it better? Yeah. Let me draw it better.
Like,
So that's the right angle. Yeah.
you know Ryan? Never means.
Why don't I? Yeah, better, slightly better.
Okay,
Wow.
so this is d minus r times d plus r, right?
Okay, D minus R. D minus
So d minus r is, so d is the distance to
R.
the center, right?
Yeah.
So d minus r is this bit.
Okay.
Yeah.
So D plus R is just
Them added.
Yeah.
Yeah.
Yeah, d plus r is,
Oh yeah, because it's
D plus R, what?
because it's the case when
Wait, what's D plus
Oh wait,
R?
when it's tangent,
when
and
it's
then yeah,
it's like that. Yeah,
Yeah.
it is.
yeah, because it's
Because,
d minus r times d.
Because it'd be the circumference, right? Then it'd be like up to here. Then that'd be d plus r.
Yeah.
Yeah, yeah.
And then that's the
Yeah,
case
exactly.
of the special case of the thing.
so then this is d plus r, right?
Oh,
Excellent.
that's really cool.
What?
Okay.
Because the angle would be.
Yeah, I guess I'll save you some of the trouble of So I think you guys already know how to verify that this is constant for all the different cases, yeah. But we just have to be kind of aware that. Okay, so maybe some obvious things. So if the power of the point is on the circle, right,
Then it's just off.
then it's 0, right?
Oh, yeah, it's
And if it's outside the circle, it's positive. Is it positive?
yeah.
Yeah, and if it's inside the circle, it's negative. Is that right?
Yeah, because then r squared is larger than d
Yeah. So they don't actually define it till later.
So what's
But I
the,
think
like,
it is d squared minus r squared.
What's
Okay.
the point of the power of a point?
Yeah.
Oh, good. Okay, so
Like that seems like arbitrary numbers.
Yeah.
Oh.
okay, so
You said
usually when like people come up with new theorems, right?
Who's your wife?
They justify it like, well, most of the time it just looks nice anyway, but like they try to justify it by solving a problem, yeah. So the problem that they tried to solve, that was in this book,
Did it work?
was this thing called some
When you said
formula due to
power.
Euler, okay? So in the book it's stated as theorem
What's the optimal angle?
2.12. So this is actually what I had on the board before. Do you remember the formula?
Oh yeah, yeah.
D squared equals
Oh yeah, the encircle thing.
yeah r squared minus 2r. So in algebra, if you use the same letters to denote something, you hope the ideas are similar too, right? So you're gonna have to let D be the center, like the distance between the center of some circle to some other point, right? So basically, that's the theorem, yeah.
Now what's the big R and little R?
Oh, in circle.
Yeah. So this is in radius, right?
Circumradius.
Circumradius.
Of what?
It's called subliminal teaching. I just put the formula there in the room, and then hope you just like subconsciously prove it.
Yeah, I know.
What? I don't even know. Like, is that of a triangle?
Distance between
There's no rule for any shape.
distance between
Yeah,
in center and
shape is
circumcenter. Yeah.
Center, right?
So this is for a triangle.
Oh,
This is
in center is when you draw a circle inside the triangle,
Yes.
and then the center is that.
Yeah.
Circumcenter is what?
So they drew a diagram. So they drew a diagram.
last year in the AIMO. I didn't know what circumscribed meant.
Oh.
So I just guessed it.
Oh, you know, like in this year's the senior one, it had a question. It was like, these conditions on a quadrilateral,
Yeah.
and then the first part was like, prove it's inscribed, and then it says, then i.e. it's cyclic. I'm like, what? and then the second part says, prove it's circumscribed.
Wait, what's the
I-
difference?
Yeah.
Wait, what?
So the first thing I wrote on the board was like,
Oh, you wrote on the board to like.
I had to
Any
clear that up
triangle
because that's
that
retarded.
is circumscribed and
I think they just got an English problem,
Yeah,
but they
yeah.
basically they're worth the same points, so it didn't matter. You had to show both, right?
Oh,
But yeah, like I think because circumscribed in English means like it surrounds
okay. Around
it.
it, yeah.
Yeah, but like it's not necessarily clear that like you know
You have to draw
like
it out.
what's it's circumscribed in or circumscribed by? Yeah.
What's the circumradius? What's the
Mine.
circumradius?
A circumradius is the radius of the circumscribing circle.
Yes,
Multiply by 4.
And then it might prove for the
What's the optimal angle to stick
actually
before?
I
know what a
circumscribe. I use the word circumscribe like 8 times
I
in
know what a centroid.
I don't know. I'm like,
How do you
let's
know?
go for points. A circumscribe.
Yeah, but we
is the
always
same
remind you every
circle
time anyway.
as this one.
Okay, so you have a triangle ABC, yeah?
Mm-hmm.
That's C, that's B, and that's A, yeah? I mean, this is a nice formula, yeah? And it kind of, like, if you can prove a formula using the concept, I don't know how much, like, there's a whole lot of other stuff, but, you know, like, it seems to be using the concept.
You know this spherical cap, right? Oh, you know this spherical cap is.
What's the best angle to stick your in the
Like that.
Okay, so you take the angle bisector, right? So you know the angle bisector meets the in radius, yeah? So that's the in radius, yeah?
Why stop playing watermelon and eat it?
Hey, I'm not repeating myself, yeah?
Yes.
So you just become more lost. It doesn't make me happy though.
Hot time again.
Okay, and
So
then
you drawn all the angle bisectors?
and this is the in radius, right?
Yeah.
Okay, and then the circumcenter. Oh, okay. So here's an interesting.
Can't be.
Okay, so let me just make a point. So can you see that the angle bisector here goes to the midpoint of the arc BC?
Yeah.
Yeah.
Is that obvious?
Yeah.
But
Yes, it
consider
does.
center.
Because it's
Because the formula for.
Because of the
yeah.
Okay. So
So
if
is
you
that
take
direct-
the midpoint of
so
this
the angle is directly
and you
proportional
join it to the
arc.
center, right? Huh?
So what you're saying is the angle at an subtending arc is directly proportional to the size of the arc.
Yes. Yeah.
That's the formula for
That's
arc
how
is
you get an arc.
formula thing.
Yeah.
Ew, that's awkward.
Yeah. I mean, okay. So look, if you join this to, okay, it's gonna have to go dotted because I don't want to make it intersect that point. But like, it passes through the circumcenter at some point, yeah.
Yeah.
Yeah, and it's 90 degrees and it's bisecting that, yeah. Okay, that's the diameter, yeah.
Yes.
Okay, cool. Then you join. So this point you call M, yeah. Then you join this to
That's a
here, huh?
It looks nice.
Oh yeah.
And then
Thanks.
that's 2 alpha.
That's yeah.
Wait. Yeah, it's alpha.
So alpha's here, yeah.
2 alpha.
That's
Oh, yeah, it's alpha. Not
Alpha.
Yes.
Inside
Yeah,
is two
alpha. Yeah. And can you see that this is also? Wait, hold on.
Oh, it's a big
I joined this here, right?
Yeah.
You see that this is also
That's
alpha.
diameter.
I don't know.
Yeah, it is.
Yeah.
It is, right?
Yeah.
No.
Yes, it is.
Ah, I get it.
Wait.
Yes, the big ammo thing.
Yeah.
Wait,
Then
so
it
it's
makes
like
sense.
this.
MO invisible point is diameter, so then it makes sense.
Wait, what's the
This
inside? What's the origin? Find out.
I is I
Like,
center.
I
O
think
is
like she
circle
was like we
center.
weren't meant. Like,
This
this
is
isn't our level. It's like higher, right?
The radius,
Like,
center of the big
skills, we
circle.
were meant to like draw these,
Oh.
and then like it was
Tricky,
I.
right?
In
Yeah.
center is the center
But
of the
then
small circle, which
I
I
was
can
like,
draw.
this is boring. So then I used calculus.
O is the center of the big circle.
Oh,
I get it
now.
I is the center of the
Okay,
small
so
circle.
do you get that this is alpha, yeah?
Yeah, yeah.
But it's not
Do you get
drawn,
that this
it's
is
just
alpha plus beta?
an assumed
Yes.
circle that's
Wait.
tangent.
Yeah, because
It's exterior angle.
yeah.
Ah,
Yeah.
okay.
Oh yeah,
Because
yeah.
yeah.
Sure.
Okay, so then this is isosceles.
I keep
Yeah.
thinking that
Oh.
I and
Whoa.
Oh.
Whoa.
Okay, so then basically, can you see that we're actually just trying to figure? Oh, this is r squared. Remember? Sorry, it was r squared. Yeah.
Also wouldn't make sense.
So basically, we're trying to figure out the power of a point, right? For I,
Oh,
Oh,
yeah.
yeah.
Oh, yeah.
yeah, because d squared minus r squared.
equals -2.
Yeah. So we're gonna find the power of a point for I, right? Because D is then that, right? But the point is, you can take any chord, right? You can take anything. So we can take A,
What's
L.
a certain radius again?
It's the radius of this circle.
Yikes. That's all I can say for you. Yikes.
Yeah. See, that's why it's never. You can come as late as you want. You can always catch up to these guys, because yeah.
I get it now.
Yeah, you can come at like 8:59 and still catch up to these guys.
Because I just started listening.
Just come here for 1
You
minute.
have 1 minute of listening.
You could watch the recorded stuff as it's being recorded and catch up to these guys. Okay.
I think you'll surpass us if you watch the video.
Yeah, it's like saying catch up is just a euphemism for surpass quickly and readily. Alright, so those are equal, right?
Yes.
So what are we trying to figure out again? It was like Li times Ai, right?
Yeah.
So now we can do BL
Times.
times,
I actually need a
so
book.
BL
Go get it.
times
See the book. I practice for that.
AI, right? Yeah. So can you see that
Isn't AI equal to
BL?
Mr. Droopy times. See, this is cool, but this
No. This is not the center of the circle.
Oh.
Yeah, we didn't even draw the circle for which it's the center of.
Never mind. Yeah.
No, isn't that the big circle?
That's how powerful this method is. We don't even draw the other circle.
I think
That's what we were confused about.
I get the formula now.
That you were
So,
wrong about.
it's that times that.
Anything that saves us drawing diagrams
Plus
may
R squared
actually be very
is equal
powerful.
to these.
You're just
Okay.
repeating what the
So
formula
BL
I'm
says.
so smart.
Okay,
You're just
so the
repeating
point
what
is
the
when
formula says.
we have
Except
basically
it's
both
simple
of these
with
things,
that.
right? Inside right angled triangles with alpha as an angle and some R as the other side, right? So here AI, where's AI?
There.
Yeah, so AI is in this right triangle, yeah?
Yeah.
So sine alpha,
That's
right,
disgusting.
is equal to
What the hell would you do to it?
R on AI, right? Yeah? Okay, and then in the big triangle, see the diameter triangle?
Yeah.
That's right angle too, right?
Oh yeah, because it's a
See,
diamond.
see how big that right
Yeah,
angle
yeah,
is?
Dude, this triangle is
The
actually.
diagram is not scary.
Whoa!
Yeah.
The diagram is
Hey.
very to
Why
scale.
are there big?
That's close to 90.
Yeah, that looks slightly near that is.
Hey,
But
that's
it's tilted.
that's not obviously not right angled. Okay, so
Which is about the best you can do.
To
when
the
you're-
nearest 10
it
degrees.
almost feels right angle, like you might even like not realize it's 9 degrees, but from the
Right.
diagram you're like, oh, wasn't that 9 degrees? Okay, so-
on
Oh,
A-
you are
ML.
So sine, it's also got alpha, right?
Yeah,
So sine alpha is BL
on ML.
Wait, so how do you prove it was right angle? Like,
BL on 2R, right?
did you
Yeah.
prove
Yeah.
that it was right angle?
Yeah. No, it's a diameter.
Oh, okay.
Yeah.
It just doesn't look obvious because O is like so slanted.
Yeah. Okay, so if you do, so BL is 2L, sine alpha 2R, right?
Yeah.
And AI is R on
Yeah.
thing. So when you multiply them together,
Oh my.
AI
You
times
deserve
B.
that.
yeah, so it should be equal to 2RR.
Yeah.
I don't know why it's negative. I guess it's actually the negative of this when it's inside, right? Because
Yeah.
the formula was negative when it was inside, right?
Yeah.
But this is always positive.
Oh yeah.
So it should be the negative of that.
Because when you square something, it automatically
Yeah.
becomes positive. So you have to take the negative case. You have to take the square and put a negative.
Alright, does that make sense?
Yeah.
That's theorem 2.12. So I guess we don't have time to go through the exercises. But actually, maybe we do. What is the algebraically smallest possible value of the power of a point can have with respect to a circle of given radius r? Which point has this critical power?
Negative 2R squared.
I have to cut it.
So the question, the first exercise is, what is the smallest possible value of the power of a point? So you guys, we're good with this theorem.
Negative R squared. Wait, oh yeah, you proved it, right?
And this power of a point thing is kind of like a junior intermediate topic
Oh.
for IMO.
I'm gonna go home and I'm gonna read the whole. I'm gonna watch the whole video.
Okay.
What video?
So could you please post it?
And then your mom's gonna watch you being retarded in that.
Why are you watching it listening to
I
yourself?
can do that, but I
Do you want to be my editor?
I was watching
This
like
is so adorable.
recorded
Okay.
and it's just David in the background. And my mom walked by and it's like, isn't that David?
What's he screaming about? It's a time.
No,
It's a
it wasn't an
timestamp.
answer. He was arguing with him about who's more retarded. Was it that?
What? It was a legitimate argument.
And then he went off at him for looking up his side history. And I was like, oh my god. And then they started getting the water and spraying each other.
What? No, he started spraying me. No, I started spraying him.
So this is why they shouldn't make too many rules in school, because then they don't really know the natural behaviors of the
He
children.
acts like that at school though. Yeah.
Do you really want to know the natural behavior of the children?
Yeah, so the first exercise, right?
One person triggered him during
Oh,
first class.
triggered.
And then he like started spraying, and then he like, started getting into a boxing match, and then I punched, and I started to punch the teacher because she got in the way.
Okay, so the first one is, what is the smallest value of a power point?
Oh.
They have a circle of radius r.
Oh my. Okay, stop that. Okay, you can stop that.
What is the smallest value? So remember, it can be negative, so it has to be inside the circle, right?
You can
You
stop that.
steal my paratha.
I like the paratha.
And which point?
Paratha.
Where is this? Yeah,
Would you like some of my paratha?
for this smallest value.
You actually can
Yeah.
stop that.
Go away.
Yeah, I guess it's just the center, right?
Also, I might have to.
So then it's minus
I might have to get agitated.
r squared, yeah?
Get
And it's
agitated.
at the center.
It's gonna get agitated.
It's
Oh
like
my god,
you-
that's so
you-
scared. Oh my god.
You get agitated. You can sit down.
So what is the locus of points with constant power?
Oh, it's just a circle.
Yeah, so the circle I guess would be power 0, right?
Yes.
What about other constants?
It's just another circle.
Well, ask them out. Why do you think that?
It's just circles of different
Yeah.
sizes.
Yeah.
Because r is fixed, it only depends on d, right?
Yeah.
So-
So it's just
so-
concentric circles of different sizes.
Yeah.
There's lots of concentric
Okay, so
circles.
that's 2.2.1.
Locus is
It's gonna get
stupid.
me very.
If the power of a point has the positive value t squared, interpret the length t
It doesn't hurt.
geometrically.
Someone spread it right like for a day.
Okay, so if the
It's
power
like-
equals
like that.
say L squared, right?
Yeah.
Interpret L geometrically.
So it's like
What?
it's like this length. It's like you have
What's
R
L?
and then you
What's
have
L?
this.
Yeah, yeah.
Power.
Yeah, so
Power.
Pythagoras is the other
Pythag,
side.
yeah.
So if you join R in the
Oh, okay.
like,
It's the
other
root of
side
power.
of triangle.
Is it outside or inside? It's outside,
outside.
right? Because it's positive, yeah?
Yeah.
Some point here,
And
that's
then,
d squared, yeah?
and it's just
And that's the hypotenuse.
yeah. And then you have like R squared.
So r squared's here, yeah?
And then that's the little height thing. Oh, the tangent.
Ah, okay. So it's the
Yeah,
length of the
that's
tangent.
Yeah.
I don't think D should be squared.
So this is the length
Diagram.
of the tangent, right?
Where's the small r?
L is the length of the tangent.
Yeah.
Oh, good
That
stuff.
might be small r.
That's only when it's outside. Yeah.
Michael.
Well, then inside that
Michael,
wouldn't make
it's
sense.
meant to be
It's
small.
negative. You can't.
Michael.
Yeah.
It's
Then
not
what's
really
that?
like
Or big r.
Big R.
Is that 3 long? Oh, okay. What?
when you
No,
really
you know
like
about this.
Wow, that's r.
Oh.
centrifugation.
Okay, there's a bunch of more exercises. I'll send them to you, okay? And
Okay, time to actually do exercises.
it's not compulsory, but it does give me a lot of information about your conscientiousness and behavior. And
Well,
and
I
interest.
haven't done a
That's
single
too tough.
It's like, yeah.
exercise with the ones you sent me.
But sometimes people look like they're just silly, but then when they get home, they just like never stop.
Yeah, people like me.
Why did you say that?
See, people think I'm silly, but in reality, I study so hard. Yes. Yeah, 24/7.
You do.
I really do.
Stab.
You definitely do.
Yeah, for sure.
That's such a bad idea. Stop. Can somebody eat that?
Yeah, and I guess we don't technically have enough time for the next section, though it's really easy, okay?
What's the next section?
It's called the radical axis.
What are you doing?
So,
Somebody actually.
let me just...
Three-dimensional.
How would you think if I eat it?
You need to put.
So So let me just write the next theorem. See, the thing is, you haven't been here. So the culture I'm trying to get with these theorems, right? You can actually basically like try to figure it out yourself. Even you can do that. You can try to figure out which cases the proof doesn't cover, if any, right?
Wait,
So we're trying to be rigorous.
You still haven't told me the main implications of the power. You only told me
The one.
the derivation of the power of one.
No, I showed you the theorem. The d squared equals r squared minus 2rr.
Yeah.
Yeah, that was a formula which we used the power of a point to prove.
Then it makes you circle.
Yeah.
Yeah.
Isn't that the
But that
point
formula
thing?
exists without saying power of a point, right?
So small, but it's
That was the justification.
I had to eat 6
Oh, okay. So like,
you can take under
but like, what does the power of the point like? Say this, the power of the point is of this one is this, and the power of the point of that one is this. So
Yeah.
what does that say about the triangle between them?
What G?
Would that be covered in the theorem?
Geometrically.
Maybe, yeah. So I mean, yeah, like
I ate 6 ratas.
How?
Because I'm skilled. I just squished them together and it's
That's wait, aloo paratha or
Okay.
Huh? Is there potato in the paratha?
okay. So the locus of all
That's
points.
so bad.
So this is the
Why
theorem,
would you
okay?
put potato in
Because
paratha?
that's what you're supposed to do.
It's sweet. You meant to put it in honey.
What?
You say you put honey in
What
paratha.
is wrong with you?
What is wrong with you? It's so bad.
I love paratha.
Locus of all points
He doesn't even know what it is.
whose powers.
What do you mean? Why would you put potato in paratha?
It's a savory thing.
It's a sweet thing.
No, it's not.
I'm fish Indian.
With
I'm
respect
fish and Indian.
to two
I'm very sorry.
non-concentric circles.
I do not
Oh, I
understand.
thought you said with respect to us.
With respect. Isn't it like
I thought
eventually
you
why
meant talk
with
with respect.
respect to
That's why I said I'm
yeah.
fishing Indian.
And when I was
Yeah.
supervising classes, like some people were just mucking
Yes,
up, right?
yes.
And I was like, it looked like they were actually having a lot of fun. So I was like,
In
they were mucking
reality-
up in class, but they look like they're having a lot of fun. I was
In
like, oh,
reality-
that's fine, right?
Rather
And then the
than
bell goes, and then they like couldn't get out of there faster. So they still prefer to be separate at home than together in class. Okay, so the locus
Wait,
of
what
all
is
points
this?
whose powers with respect to two non-concentric circles
Just got 1, 2. It's not special.
with respect to two non-concentric circles
I hate sometimes it
are equal.
says like the set of all points. Oh, my nature is not a
Are equal. So that maybe you can pass this here. Is a line
I'm just vibrating my phone.
perpendicular
Whenever I do this, I just do this.
to the line
I do it, but not no.
to the line of centers of the two circles.
Calm down.
To the line joining the center of the two circles.
Okay. Equal. Wait, no. It's just like equal.
Yeah. So basically, you have two cases, right? You have like this case.
But it's intersecting and then not intersecting.
Yeah. And then you have the case where they're not intersecting. Maybe you can help me list the cases, yeah?
I got you.
I can draw this smaller so we can. Maybe that's suggesting there's only one case.
That's
The size of the case.
This one is more important than the other.
Maybe this suggests there's lots of cases.
Okay, so wait,
Yeah,
what? The
tangential.
locus of all points whose power
But
is
there's 3, right?
That's really fun.
Yeah.
So how many non-concentric
Yeah,
circles are there?
Game ends.
It's like
Stop.
I got you.
yeah.
Yeah.
Yeah. So there's another case like this, right?
Yeah.
Yeah. There could be tangent, yeah.
And then the line just like.
Got you.
Yeah. They could be tangent like this, couldn't they?
Oh. Ooh.
Yeah.
Oh, we have not considered.
Okay. What else? Anything else? Or it could be like this.
No, but that's. Oh wait.
It's like non-concentric. Oh yeah.
I think, is there an Olympiad problem saying there
I
are
can't draw them concentric anyway.
Wait, is there an Olympiad problem saying there are 5 non-concentric circles? There are n non-concentric circles. So how many
I didn't get the
How
question.
many,
I didn't
like-
get the statement.
Concentric is.
how many ways are
having
there
the
to
same
draw them?
center.
like this.
Oh, what's that?
That could be
That's the
another
exact same
problem.
Yeah,
Why?
but like thinking about how you can draw circles kind of
Wait,
it
so
basically
Well,
convinces
it's
you
just a
that
circle
like
with the biggest center
that's why
on
there's
top.
only a unique circle through 3 points, right? Because there's no circles that intersect 3 times.
Wait, the locus of all points whose powers with respect to the
Technically, it's
I didn't get that one.
Yeah. So I mean, this is one case, yeah.
That's not the.
That's fine.
It's
Oh,
not two
okay.
separate cases.
Wait,
So one is big.
Yeah, they're not like the
Yeah.
cases of 3 circles, and that one's like
three
that.
circles, how many cases?
So I mean, can you kind of figure out where
This
the
is 10.
so I guess we don't have enough time to prove it, but can you kind of figure out roughly where this radical axis is? So when you have 2 circles, right? You have like a point. That point has a power with respect to one circle, right? And has a power with respect to the other circle, yeah?
Wait, so just the locus, the vertical axis, like the line.
Yeah, so it's the locus of the points where they have equal powers. Yeah?
Oh, like respected to 2 different.
Yeah.
Oh.
So yeah.
Because they have a power point for circle
okay.
1 and a power point for circle 2, right?
Oh.
If
and
they're
then
both
they
equal,
I
like
get
all the points where they're both
I get.
they're
Yeah.
equal to each other.
I get.
Yeah, but even if they're concentric, it's just the center, right?
Yeah.
I don't get this.
They're both equal.
Is the line perpendicular?
But the center's on it. So, but the reason they say non-concentric is because concentric perpendicular doesn't make sense, right? Because you don't have a line
Yeah.
that joins the center.
But first, is it a straight line?
Oh, it's claiming it's some line
But
perpendicular.
like, can
Yeah.
we just prove this lesson that it is a straight line?
Every case.
Like it's not some.
You can basically
See,
have the idea that it's a straight line, but I don't think we have enough. We have 1 minute,
Oh, okay.
so we can't prove that it is a straight line. But I can sketch the proof quickly. But
2 points make a.
That's not some sort of like
2
the.
points
It's
make a line.
it's a locus of points. Remember the locus of points where the power of those 2 circles.
and a circle.
so, for example, let's look at this case. Yeah,
Inside
let's look at every case and like find at least 1 point that's on the locus. Yeah. Okay, for this one.
So
Where
for the
each-
tangent one, where they intersect.
Where each point has
Yeah.
the
So can you
same
see
power.
that this point here is on the line? Yeah.
And this
Yeah?
is the
What is that?
distance.
So that point is the point of intersection
I-
Center.
because
No,
it has power 0 with
Yeah,
respect to
I
both
understand.
circles, right?
Yes.
So they equal 0. Yeah.
Yeah.
It's D squared.
Does that make
minus
sense?
Yeah.
This guy.
Um,
Yeah.
That's the.
So here it's the same, right?
Because you can
That's-
use it because it's-
He's just not intersecting.
Yeah. So actually, can you see every time it intersects, it's on the line?
Yeah.
Yeah.
Where else would it intersect?
Huh?
Where else would it intersect?
It's 2 intersections.
And then that
Oh wait, like
that's automatically a straight line.
Yeah.
Yeah. So when you have 2 points,
It's
see, it's forcing it to be that line. That's what it's claiming, right?
Yeah.
Yeah, but
Okay.
you have
Yeah.
to still prove that it is a line. There's not some other kind
Yeah.
of weird combination.
What else confused?
Like a
Like
curve.
any 2 points.
Could it be a curve tending to the one that's bigger?
But like, let's say the points say you just make the line dodgy.
So what's this?
Like I mean,
Just have a line like this instead of like this.
So that's D.
no, I mean like we still have to prove that this locus of points is like going through like here instead of what if it's like crossing these 2 points, but it's something like
And then you just
here
draw the tangent to that.
or something
Why
like
can't
that.
it be that?
Yeah, that's what we have to prove next lesson. Why can't
Okay.
it be something like that?
Right?
Why can't it be something
When are you
like
sending homework, Michael?
it's like can't be like some
tomorrow. But the
something
thing,
like-
you can even maybe prove this yourself. Actually, you it's almost like you're almost fully equipped to prove this because you don't even think of the
Using
other proof. You think of the proof you learned in school. But anyway, so
what proof did we learn in school? We never learned.
okay, so it's clear that anytime they intersect, that point is on the line, right?
Yeah.
Yeah. So this one, for it to be a line and there's 2 points, it's basically saying it has to be that one.
If it intersects also on a line where it's like the,
What if it's
the
not
joints
like
are 2
that?
centers, right? So it'd be the
I doubt this.
intersection of the line, 2 lines.
Jeez.
You mean
It'd be like when they're perpendicular.
yeah?
Why is it wet?
So is it obvious like when there's these 2 circles? When it's these 2 circles, for example, right? The point, the locus has to be outside both circles, right? Because it can't be inside both circles. Like if it's equal to negative number, then it has to be inside both circles,
Yeah.
right? And it can't be inside both circles.
Oh, it's, yeah.
Yeah, so it has to be outside both
This is
circles.
the one, right?
Yeah.
So you have This is.
So something like that.
Similarly, it can't be on both. Yeah.
Yeah, it can't be on because it's not intersecting.
But what if it's like curving to the bigger
Is
circle?
defined as d squared minus r squared.
Yeah.
Yeah, so that's something you can kind of figure out.
Because like sometimes you can think perhaps like the bigger circle has more like influence and like.
Dude, Kavan, why do you spill all that water? Oh, that was you.
No, this guy was like
Come on.
tickling me, and then he put, and I pushed him like back. Because
You know these guys, what they do, like last time they just spilled the whole coffee on the floor and
We
they
did.
just
Oh,
left it there.
Wait, when?
What?
Yeah.
When? That was him.
And he's like he's
I
done
wasn't
it so
even
many
there.
times he doesn't even know which one
I
it
wasn't
was.
even. Wait, when was this?
You don't know how many times, and then the spillages here
But when was
are
that?
epic.
Coffee.
But
coffee.
That's excusable.
Coffee.
Huh?
With
Oh,
coffee.
don't
I
worry.
didn't
No,
say
you didn't do the coffee.
I didn't do the
I'm just trying to make it. I'm trying to frame you.
See, the people who spill it, it's like I'm there, but it's always
Wait.
either Kavan
So is it clear? Is it clear that
You're pushing it up. You're tickling me.
Oh, it's mine, right? It's mine.
Yeah,
right?
it's yours.
Is it clear that it's
You're
straight
drinking
on?
from
So
it
here-
last.
Yeah.
It should have been my bag, but you wanted
Huh?
it to drink.
What you say?
all right? Since you're all here still, maybe I can just sketch the proof. Yeah.
Sure.
Okay, but that's not gonna be.
So this
But
is
like-
probably the easiest way to prove this with stuff you know, right? Just coordinate geometry. Yeah.
Yes.
Coordinate geometry is really easy. So
Wait, so could you explain that theorem to me?
this theorem.
Yeah.
So do you know what PowerPoint means?
Yeah. It's like when you draw that thing. and
D
it's like
squared
that
minus
point,
R squared.
Which is
Yeah.
like D
So you
squared
have,
minus
but that's for
R.
one circle, right?
Yeah.
Now you have two circles. Okay.
Okay.
So it has
That's
two
what he's
powers.
explaining.
It has two
What
powers,
are you
right?
doing this
Yeah.
entire time?
So sometimes they're different, sometimes they're equal, right? When it's equal, we want to count it in this locus.
Okay.
So the locus of the ones where they're equal,
Yeah.
we're saying is a straight line, perpendicular.
Yeah.
Even
So-
I do that.
So the ones that when they intersect, they're both equal to 0, right? Because when it's on the circle, it's the power 0.
Yeah.
So if it's on both circles, it's power 0 with respect to both circles.
What do you
Yeah.
So then the intersection's on the line.
So it's always on the line.
Get out.
Alright, I'm done answering your question.
Yeah, I know, right? Like, wait, what? Okay. Is that
But isn't it because like d is fixed? Like d is fixed because if it's the perpendicular bisector,
Kavan?
There's like
d is fixed,
What's the
yeah.
point in?
And then
You're spilling water on me.
d squared minus r squared, but then r squared isn't fixed. Though.
No, these are. I'm not.
So if you take two circles, right? You can like maybe
And they're equal to each other.
Yeah, yeah,
They're equal to each other. Like the
you
fixed
can
between
define the origin to be the center of one of them, yeah?
Yeah.
Just to be nice.
nice.
And this is R, this is big R, right? Yeah? And then you can actually just calculate some stuff. Yeah?
Oh yeah, solving geometry with
You take
coordinate
like a-
geometry. That's my favorite.
Like an XY, yeah?
Yes.
Yeah.
Oh yes.
And do
Oh,
a
yes.
PowerPoint. For some reason this is how the book does it. It's funny because like the book does it
Is
as
this
a
school
a refreshing new way to do it.
then
And
this
this is
is-
the thing you do every day at school, it's sad.
You learned this in school, right? Refresh.
Yeah.
Of course, we learned this in school, not normal geometry.
So you can kind of calculate the power of a point, right? With respect to that point.
So d between them is equal, right?
So that's called the
So
power.
that's
D,
x
right?
squared plus y
What were
squared
you doing this entire time?
Root, square root.
minus
No,
r
you
squared,
what?
right?
You didn't even know what a power
Yeah.
point was. Even I was
And then
listening.
this is maybe this could be a,
I
yeah.
don't think we used this.
That's d, right?
So this is x minus a all squared
Yeah,
plus
it's
y
minus r squared
squared
between 2 points.
minus r
And
squared,
it's a
yeah.
Because it just
bisector of
is.
those 2 points.
So can you see that the x squared plus y squared cancels? Guys, can you see the x squared plus y squared cancels?
Yes, it
Yeah.
does.
That makes it a straight line then, right?
Yeah.
Oh.
Oh yeah, because
Yeah.
Oh, because the R
Or
squared.
it could be trivial, yeah. But like, so the x squared y squared cancels, so it's minus r squared equals minus 2ax plus a squared minus r squared, right?
Oh yeah, yeah.
That's a straight line. That's a.
And we can calculate its.
But then yeah, should
And where is it? You can even calculate where the straight line is, right?
Yeah.
So it's x equals something. You see that?
Oh yeah.
That feels so.
So it's x equals something.
So it has to be
So-
vertical.
So it has to be perpendicular, right?
Yeah.
So the gradient is not. I was just about to say find its gradient, but then I realized the gradient is not
Yeah.
existent because we set it up to be horizontal.
Yeah. So then this is
Look at that.
a squared
And
plus
then knock you backwards
R
and you knock them
squared.
out.
No.
It really was there.
plus
It was
r
not from way
squared
before.
on
You
2a.
just
Yeah.
now about to pick it up. You
No, it wasn't.
Yeah, it was.
And that would be a lie.
Yeah. So and this is basically it, but it's not quite approved because the circles don't have to be like this. Yeah.
Yeah, it could
Liar.
be
So we kind of
You're so
assume.
stupid.
Well, I don't know. Did we assume a was bigger than r? We maybe not, right? But
Well, the circle can be any arrangement. So.
but the point is, for it to be a proof, you have to be convinced that it covers all the cases, right?
So this case is trivial, right?
Well, let's do this.
So this case is trivial.
No, I
Is
don't
it
want to
trivial?
do it. I don't know.
2 points make it right.
Yeah, no, but how do you know it's a, oh, you know what, how do you know it's a straight? Oh, I guess.
Well, let's do
Yeah.
it.
It's straight line, so like that never changes.
Yeah, I mean, so if you're commenting on the fact that we don't really assume that a is bigger than little r, then this maybe covers that case too.
Yeah.
Yeah. Right.
Oh, I get it now.
It doesn't have to be here. But then we still have the other 3 cases.
Stop it! Come on, hey.
I'm not doing anything.
Wait, this would be a good Olympiad problem. Like there are 2000. Hey, so
So
2019
the power
circles. So
Let's keep
2019
like
circles.
that,
How many
sets and
unique ways are there to
sets.
draw them? Like as in this one.
Oh.
But as long as they're non-consent.
I'm not sure what's the theorem with 2019 circles. How many cases does it have?
Yes, that should be an Olympiad problem.
There was a question with 2000 something circles. It was like you had to show something about that no.
Stop!
Yeah.
What is it?
Oh, there was a problem in the tournament of towns about lots of circles with the circumcenters. Or lots of
Oh,
points.
yeah.
Lots of
Lots
points
of
where no
points.
3 have. Oh.
You can have flexible.
There was like a ton of points, and then there was like every circle, the yeah, I can't remember now.
Let's keep it there.
Oh,
Oh wait, yeah. You showed it last time.
Yeah, a long time ago.
Oh,
Oh,
I
I
forgot though.
I was doing the ones
Oh.
like where how can you
Okay.
construct
No.
a certain angle using a compass so many times?
Oh yeah, yeah.
Oh,
Okay,
you
why
did
are you
that
puffing?
Yeah.
long time ago. Yeah.
Why are you puffing so much?
Because I love puffing.
Okay, that assume then I assume that you.
Okay. Yeah, so this is pretty good. I mean, I'm assuming they're learning something like this in summer school right
If you're
now.
puffing, that means
I
you
think-
want
I bet they're sleeping.
Yeah, they're sleeping.
to puff with.
Are they?
No, it's probably like they're doing the same thing these two are doing.
They're probably playing games.
Hey, they got a summer school